Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics. Welcome to Speaking of Reliability. This is Fred Schenkelberg with a quick button on the record because we were getting into it.
Yep. And this is Kirk Gray.
Yeah, Kirk, It's one of these things. You brought up an adhesive challenge, and I was thinking about one of the topics today is wasn't tied to adhesive, but is there some things that halt testing just can't find? And the easiest way for a halt not to find an issue is just don't run the halt, which is kind of part of the problem. But we were talking about adhesives a little bit and failing and sparking a recall on a vehicle. But I ran into one years ago where it was my very first consulting job when I first became or not the first, but I think it was in the first month I did it, and it was a hot tub, and they were using it kind of like an extruded panel, like a piece of wood, or I don't know, it was like 2 feet wide, but they extruded it, big fat chunk of plastic coming out of this machine. And the little bit about plastic I understood is that the coefficient of thermal expansion was greatest in the direction of the extrusion, because the polymers basically get lined up with the direction they're being pushed out of the machine. And they were worried. They were finding that those panels, after a month in an application where it sees full sun and then it gets cold at night, and so it gets that daily thermal expansion cycle, is that the adhesive they were using to glue these things onto the frame, and it was purely decorative. It had no structural element to it. There was a frame that held the tub in place and the motors and all that other stuff. But this was just to give it a aesthetic of like a fake wood paneling is what it looked like. The company will remain unnamed. But they were just putting a DAP. I think it was actually like a DAP product of some sort, some kind of adhesive, industrial adhesive. And they just glue these things on, and after a month, they'd fall off. And I was like, that moves. And they go, we know. Why doesn't the adhesive deal with it? And I'm like, is it meant to move like a half an inch? How did you know it was that far? I says, well, you've got a 3 foot long steel, and it moves the most in this direction. It's probably at least a half an inch. And so I was able to draw on my previous experience and everything else. And if that, and even with solder joints, they move. To deal with the CTE, the coefficient of thermal expansion, is that solder joint is not rigid. It's not welded on, for example. It's allowed to move and not break. But when you push adhesive too far, it doesn't take much for it to. It's kind of like a crack, right? It starts, and then that amount of strain that point has got, it grows more, and then eventually the whole surface delaminates and comes out.
It starts to, the stress starts to concentrate around what's left in the adhesive contact connect, and it pretty much compounds itself and comes apart. But tricky. First of all, it surprises me because of the massive recall of the Cybertruck that adhesive is commonly used on an outside metal panel against, most of the time, it seems to me, in my experience with cars and panels and components, is it's mechanically attached, and to rely on an adhesive in a product that is going to be used in extreme environments of the outside Phoenix desert, or
high altitude
here in Colorado, where it can swing 100 degrees Fahrenheit in a day easily. And
you've been out camping, then
and the expansion and contraction. I mean, matching up the thermal coefficients of expansion of the two is the key, because when you have the differential expansion and contraction of the metal, which is use
usually moves quite a bit.
bit, and versus polymers, which can be flexible but still are not generally as have a big expansion.
Well, it's not like ceramic, which has a
Right,
very low CTE
right,
value, and so it, even
right.
with high temperature swings, it moves very little. It does move, but it doesn't
But you get
band
these
very much.
differential
Yeah.
stresses, shear stresses, and across the bond, and eventually, um, over time, it's going to be detached. How long it takes is really the question, and what the environment is. And
Well,
someplace like in the coast of California, where it all stays the same, although you have all salt, maybe you have
then we have
more salt.
salt and we have all the other
Right,
things that go
right.
after it.
But and my question is, how did they test this? How do they know? Could they did they put these vehicles in a chamber and run, a very rapid expansion and contraction cycles of heating and cooling the car to make the worst case and cycles and examine
Yeah,
that after, I don't think
but
they
I
did
don't
it.
think so.
I
No, I
because
bet
I
you it
think
was
they're
on.
finding it out in the field. They're finding it
Yeah.
out
Well,
now.
they're also, and you've done it before too, is you say, well, here's the two materials and let's make some coupons or mock-ups. We don't need the whole vehicle. We just
Right,
need these
right. You could
pieces.
put just a panel and the attachment, although you might not simulate the full mass and weight and stresses on that.
Well,
You
that's
can
the
still
other,
you can still
it's,
test the bond.
yeah, and thermal cycling is just one that almost always comes to mind when I think of adhesives because the
Well, shock, vibration,
vibration, shock, oil, gas,
right? All
petrochemicals,
can
salt fog, salt,
absolutely,
grit and debris, ice, freeze thaw conditions, which is a type of thermal cycling, but different than coefficient of thermal expansion.
yeah,
All of those things work to take things apart. And adhesive is,
right,
I mean, one of the things I've run into is that people will say, well, I'm just going to epoxy it. We'll get the hardest epoxy
right,
we can. And then
right.
it's
We'll get it
brittle. And
exactly
it gets brittle.
right,
And then it gets UV, penetration. It gets,
right.
adhesives are a nightmare. Just if
Adhesives
you,
are a nightmare, and like epoxies, encapsulation epoxies are, almost it's trade secrets on matching the expansion contraction of a plastic encapsulated microcircuit.
oh yeah, you
The
got to be
the
really careful on
epoxies,
that. Yeah,
right, because that's definitely going to internal heating of the chip inside and expansion considering the
you turn the
outside
thing on and
world.
off twice, and the
Right, right.
capacitor gets pulled off. I've seen that.
So those epoxy formulas are quite tightly held kind of knowledge,
Yeah, and you got
I
to
hear,
really, yeah, you have to match it just
and you
right.
have to match it. And so, and there's certainly I've been aware of cases where underfill has been an issue
Hmm.
with not
Same issue.
matching, right, where the underfill in a BGA has not matched the expansion contraction.
And it's the one that takes it apart. Then it's the one that it's moving too much or too
Yeah,
little, and
right,
it, yeah.
right.
Now there's,
But I just think why would you attach, obviously mechanical attachments, fasteners are the way I've seen most panels put on. On external parts of the car, it's adhesives internally in the car still would have be subjected to the vibration and some thermal cycling, but not as
mhm.
severe as the outside because of in
Oh
passenger
no,
passengers have to
no, you haven't been out for lunch in Malaysia, and you come back to the car and everybody opens the doors and steps back.
Yeah,
It's like a
can't grab the
furnace in
wheels.
there. Yeah, it
Oh,
is just
oh,
blazing hot.
that's it. Well, in Texas, I grew up, and yeah,
Yeah,
it would get so you really couldn't touch the steering wheel. But
that's
and
where
I'm sure
driving
that's
gloves came
true, and
from.
that's true in Phoenix. That's why I'm thinking that to me, using an adhesive is fairly high risk relative to a mechanical fastener, something that's
And
attached mechanically.
I've heard the arguments that it's more efficient. We can assemble it faster. It does
Yeah.
all these other
Oh, of
things.
course.
I've
There's
also
other
ran in.
advantages to it.
It's got advantages, and I also
Right.
ran into working with adhesives to get it right. It might, and I don't know the details of the Cybertruck recall.
No, we'll find that out
We'll
from the
find out
Astro.
later. But
Yeah,
the idea
fortunately.
is that it could be that there was a change in the formula of the adhesive, or there was a change
Right.
in the process of applying it, or there
Right.
was some other subtle thing that
Right.
affected some small number, but
Right.
they can't tell from the outside which ones are affected or not. So they got to go back and
Well,
do them all.
they said, something 1% or some low single number digit, but you and I know that that's just a function of time. That as that adhesive gets more, as more and more of the units get stressed over
Uh,
time,
now
it's
let's let's be
probably
fair to the engineers there. Let's say they did their due diligence, they did a good job
okay.
of it, and something changed, and for a batch or for a
Could
small
be,
number, it could be
lot to lot variance.
variation, or it could
Okay,
be process to
could
process,
be.
or line. It could be. So let's give the engineers a break here. They
Well,
did their job.
they would focus on a certain period of time, but right now it seems they're recalling almost virtually 100% of their production since
Yeah,
the
no, that's a
beginning.
hit. Yeah, and that's a hit. It's one of those things that adhesives in general, and I started my career as in manufacturing as a manufacturing engineer, and
Yeah.
eventually moved into more reliability and statistics type stuff.
Hmm.
But yeah, it was to be avoided as just the trickiest connection system there is. And the really good industrial ones,
Hmm.
adhesives, are
Yeah.
just toxic. They're just dangerous to work with. You don't want to be in the room when they're being used,
Yeah.
kind of thing. And so
Yeah.
got reinforced when I went more into electronics is, one of the common things I ran into with Halt, and I think is what sparked me, is to talk to you about what can't you do, is because somebody has an electrolytic capacitor, a can we call, and
Yeah.
it vibrates off, and that's your first failure. You're like, oh,
Yeah.
well, I can fix that. So they go out and get some RTV, I think it's called,
Yeah. Right. Right.
an adhesive, and then glop it on there.
Yep. Yep.
And then they find out that now they have a heating issue, or they have it's doing something else bad to your system. It's part of it is the adhesive is quick, and I don't have to redesign the board. I can, do all this other stuff. I can plop it on there. Now you
Right.
just added another component that has its own real responses to stresses, and fails on its own right, all by itself, or causes other things to fail.
That can be true. That
Yeah.
can be true. But I tell you, in the silver boxes in PCs, I'd open any of them and you'd find some, definitely components that were, had the goop on them, had the RTV on them,
But
and
I've seen
hell,
some that were
and they were,
excessive.
for the most part, most of them worked. Yes, you do introduce another potential mechanism that but it's a cheap and unfortunate, instead of redesign with like components that are adjacent, very close, and might
Mm-hmm.
be touching. They might put goop in there to keep them apart or something like that,
Mm-hmm.
and that works. I mean, it
In
does.
some circumstances,
In most
it,
circumstances,
it
90, maybe for them, 98% of this time. And
well, yeah, I push back because I ran into it with these guys who are doing there was a test rig for the very high speed transmission lines. So the big, huge, like testing fiber optic lines,
oh,
undersea cable
okay.
fiber lines.
Right.
And the stack of electronics they had to be tuned to, 5 gigabits or something like that.
Right.
And at that point, resistors and capacitors kind of reverse roles. It's really weird how the
r-
electronics works.
Right.
And they had one where they said, well, we'll just put some RTV on it. It changed the dielectric in that immediate area and affected the field. And
Right.
yeah,
Right.
it's quick and simple on the production floor. And
Right.
you can't stop and go, oh, it'll just work. Adhesives it's sort of like software will fix it. Well, it's not. It's goop doesn't. Oh, yeah, I agree with you. I've seen it plenty of times in
Yeah.
plenty of places. It
Mm-hmm.
smacks to me of poor engineering. They're not considering the manufacturing process. They're not considering all these other things. And at the last minute, oh, this might be an issue. We got to deal with it. So goop it up. I and then it's late in the program, and there's not much else you can do about it. You hope for the best. Now, I've
Mm-hmm.
run into like the team that was doing the hot tub that I opened up with.
Mm-hmm.
Um, they were looking at it strictly from, it wasn't even a design part of the design. We're going to put these panels on here. We got a lip. You stick it in there. And the manufacturing guy said, well, we'll just glue it in. It's quick and easy. Done.
Right.
And they weren't supposed to be, repairable or replaceable. It was supposed to be there forever. And they bought a
Right.
glue that they thought would survive long enough with hot chlorinated water sloshing around on it.
Right.
And they were unpleasantly surprised by how quickly it failed. And and they went to a mechanical fastener and they stapled it. And,
Yeah.
and that didn't work either. And then they
Right.
put bolts in it and cranked them down, and that didn't work either. And I said, why don't you put a slot in that bolt? And when you look at the vehicle, attachments, oftentimes it's not into just a hole to match the screw. It's a slot. It's going into
Right.
a plate on the other side that can slide.
Right.
Yeah.
Right.
But there's a little bit of thought about what you're designing and how you're putting it together. And it's the lure of quick and easy and, oh, we can just slap this together and go, is counter. When I open up an Apple product, even I opened up the Next workstation years and years ago. It's beautiful. There is no
Yeah.
adhesive in there at all.
Right.
Let me tell
Right.
you.
No, elegance of design was one of his key factors, and
Yeah.
layouts and stuff like that. But I think, what you brought up is also a knowledge of material science and the expansion contraction, and that
Mhm.
they didn't understand that, and they probably didn't test for, putting in, and it would have been maybe expensive for this as a hot tub, you said,
Yeah.
to put hot and cold water in it very quickly. I mean, of course, nobody's going to be in a hot tub in cold water, but the outside environment's going to cool down.
Well, up in Wisconsin, people would break open the ice on New Year's and go for a swim.
Yeah.
Who
Yeah.
are those
Okay.
people?
Oh,
Who are those
yeah.
people?
Okay. Yeah.
Yeah,
Right.
Texans wouldn't be caught doing that.
No.
It, no, one of the things
Let's say, have you heard of hypothermia?
oh yeah, they don't stay in there very long.
I don't think so. Yeah.
Yeah.
But anyway, so that would be a matter of could what did they do to ensure the integrity of this,
Oh, we read the data sheet. The salesman said it would work. You know, there's it's
famous
like
last
it
words.
really is. Yeah, here,
And-
it's a design freeze. We're just going to put glue on everything else.
Yeah.
Um, the adhesives are a complex component. There's no doubt about it,
Oh,
because
sure.
thermal expansion is just one, and how well it's tuned to actually accommodating the motion that's
Right.
going to occur. And that, like you said, that's a whole material science endeavor all by
Right.
itself. But they also fail with shock. They fail with
Sure.
UV. They fail with chemical exposure to petrochemicals and
Right.
other stuff.
Right. 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 They're polymer generally, I think, and
Yeah, some are, many are. And then water, you just get it in
water.
moist, will break them down. Oxygen, they'll oxidize. It goes back to, I think, a couple of years ago, we were talking about how do we create a listing of failure mechanisms for
Right.
different things. And somebody commented to me, is like, well, that's a big undertaking. I was, yeah, it might be fun. But adhesive have a long list of things they can have a problem. Now screws and bolts have their own set of failure mechanisms, and vibration's often a very convenient way to go after, mechanical fasteners,
All right.
right?
But a thermal expansion contraction also affects those, certainly
Right.
loosening of screws and bolts and
Yeah.
yes.
And freeze thaw to some extent, and the types of forces it sees,
Right.
and all those things go at. When I look at adhesive, is the first thing I start looking at is what is this particular chemical compound and mixture, whatever it is, susceptible to, and is the environment that we're putting it in going to have those, even if it's remote,
Yeah.
because
Yeah.
somehow somebody is going to put it in the worst environment for that particular failure mechanism for that adhesive. But when then you put it in a vehicle, you're seeing all kinds of stresses
Oh,
and all
yeah.
simultaneously, vibration
Oh,
and grease
shock
and
and
shock and
thermal
everything,
expansion, right,
all at once. And
right.
yeah, it's amazing anything works on a car. That's that's my official opinion.
Well, yeah, I guess I have used adhesive on my car to attach them after a hailstorm.
Hmm.
These it was a strip of decorative uh, on top of the car to cover up a seam for the roof,
Hmm.
and they got it kind of bent up. But I thought, the easy fix, because I don't mind a pimply car, and I wasn't going to pay the $3,000 to have it every bump taken out.
Well, they just
But
replace it probably.
yeah, I just whatever. I got the money out of it, and I just used some, really strong metal epoxies, and it so far it's held. But it's not a big deal. But normally that was an easy fix as opposed to drilling through this and screwing it down with a metal screw, which would look a little crazy. So anyway, but you've got to know, of course, you rely on the manufacturer of the adhesive to give you a lot of, but they probably haven't tested long-term outdoor environments on a vehicle, and who approved, who suggested this, and then with the kind of risk that it would be for a outside panel of a truck or a car, uh, that would seem to be worth special investigation, because I just don't. I'm not familiar with automobile other than my own manufacturing of automobiles, but I doubt that that well, the front windshield, I guess, is glued in, right?
Hmm. Hmm.
But it's also mechanically held. Some way around it. Is there? Is that true? I know windshield replacement is common.
Yeah, no, I
You
don't know.
could,
I couldn't tell you
yeah.
exactly of it. I don't drive very often, so that I don't have to worry about it.
Well, yeah, I've had one or two replaced, and they come out to your facility, your house, and they'll do it right there on the spot. So it's not, really difficult. But
Well, that's going to be a topic for a whole nother podcast. Is that my wife has a Subaru, and it has a feature in it called eyesight. So there's a couple of cameras looking through the windshield, and so it'll hit the brakes if you get too close to something.
that's a good idea. Yeah.
And it's been in the technology for a while. And now as you get more and more autonomous stuff and these sort of looking through glass or looking through windshields kinds of stuff. Um, so we only found out the hard way that you have to have a particular quality of glass for the eyesight system to work. Can't
Oh,
just
you
replace it with
replay.
off the shelf one.
Yeah.
And so I was like, oh, bother. But that's the subject for another day when
Right.
the technology now is making you capture to particular sets of components, repairs and replacements.
Yeah.
That's a whole other topic.
As the technology increases and the cars become more safe, I think that's there are other issues, right,
Yeah, yeah,
that come up.
there are. But that we'll save that for another discussion. But
Right.
in general, though, I think our bottom line here, Kirk, is don't use adhesives.
Well,
That's my opinion.
yeah, be very careful, but avoid using if there's alternative mechanical attachments that, they don't have the effects of aging as I think as significant as adhesives. But I don't know. There's, adhesives have been used for dec,
Centuries.
decades. Yeah,
We've
exactly.
been
We
gluing wood together and
things
they just last
together,
fine.
right?
But there's all kinds of trade-offs with any method we use. And it's being
Right.
aware of them and thinking them through and understanding that it may well be it's a perfectly good strength that has the elasticity it needs on day one, but how does it age? How does it fail? And it might be a
Right.
combination of steps that create the failure to occur. So it's not as simple as saying, oh, it meets its spec. It's how do those things change with time and various stresses. And I have found adhesives in my illustrious career, if I may say so, is I've not found adhesives to be just the panacea that we always hope they are.
Right. Right. And it's I mean, I can't think of a, I guess there are worse environments than the outside of an automobile.
Hmm.
But that one's pretty severe, considering they're expected to be all over the world
Yeah.
and in all kinds of conditions, rain, hail, snow, sleet, whatever, and extreme salt spray, possibly things like that. It just that is the worst. That's where mechanical fascination. If I screw a piece of wood to a piece of metal, I know that's going to be a better bond gluing a piece of wood to a piece of metal, and I guarantee there's probably
Yeah.
I doubt that's the two surfaces. The
Hmm.
materials are so critical with that.
Yeah.
What you're bonding and
Well,
certain
even cleanliness. Sometimes you got to
right,
clean
right,
some to a particular and prime basically the surfaces so they bond. Yeah, there's
right,
all kinds of complexities in it, and there's every
right.
day somebody's creating a new epoxy or new adhesive. So it's just something to get be wide, be very aware of what that material is and how it behaves today and tomorrow and 20 years from now,
Yeah,
and and ask those questions because it's worth doing and avoiding future issues down the road. The
right,
process also really matters, so don't stop at the design drawings. Um,
right.
but I'm just thinking, Chris, Kirk, we could probably wrap this one up. Is
Okay.
that if you're listening and got, dealing with adhesives or looking at a new component being introduced to your system or element in your system, is, what is your process to vet it to make sure it's okay? And if you're running into a bunch of hand waving and all will be fine, um, it might not be. And it's like 1 in 10 can cost you a couple $1 million real quick. And it's at least think it through as a minimum. But if you've got a story where something worked or didn't work, or what's your take on this? Now, if any of you are adhesives vendors, don't, at me because it's the, kind of thing. But let us know, what's your story or history with this stuff. And you can do that over at accendoreliability.com/go/SOR. And there's a couple of ways to get in touch with us. And Kirk and I and the other hosts are available through LinkedIn and our about pages on the site. So plenty of ways for you to get in touch with us. And hopefully nobody puts a bunch of cryocyanate on your pen. So when you pick it up, you can't put it down.
Yeah.
Hope you have a good day then.
Yeah, yeah, yeah. But the tricky thing is, and this is something we attach accelerometers to circuit boards with cryosylate,
Mhm.
whatever, I can't pronounce it, but super glue. Okay. That's
Yeah.
what it's commonly called. And it can withstand a pull force, a direct, what do you call it? That vertical, if you have it there, but
Yeah.
it
The bonding
cannot,
strength. Yeah.
but the shear strength is almost nothing.
Yeah. So you just
You-
tap the
If you remember the
accelerometer.
guy with the hard hat,
Yeah.
hanging from all he had to do was twist his body very quickly to the right or left,
And
and he
he'd
would
be
have
on the ground.
fell. He'd be on the ground. That's
Yeah.
right. So we would detach him by just getting pliers and just
Twist
quickly
it a little bit.
twist them, and they come right off. So
Yeah.
that's another thing. They can be directional.
It really can. Oh yeah. All right. Well, thanks, Kirk. I thought I'd throw
Okay,
that one at
Fred.
you because I knew we were going to talk about it anyway. So
Uh, all right.
talk to you later.
Bye.
Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.